So for our seventh example of solving polynomial equations or equations that have exponents up here, I thought I'd go maybe a little off the deep end and give us four terms here. With four terms, it's an indication that we want to do our grouping. So let's group our first two terms, group our last two terms, and see where that takes us. From the first set, I think we could pull out a 2x squared. And that would leave us with an x, because 2 times 1 is 2. X squared times x is x cubed. And then 2 times what would give me negative 6? Negative 3. And I already have the x squared here. So this establishes a parenthesis for me. I move to the second set of brackets. I want to see what I can pull out of there. And I want to be left with an x minus 3. So I'm going to cheat a little bit. I'm going to just go ahead and call that x minus 3 there. That may help me figure out what I need to pull out. So what times x would be negative 8x squared? Negative 8x, because the negative 8 times 1 is negative 8, and x is x squared. And then we have to make sure it works for the second part. Negative 8 times 3 is positive 24, and right there's my x, equals 0. And so traditionally I've been telling you, let's pull the leading terms together and rewrite what they have in common once. So this would be a 2x squared minus 8x times x minus 3. Yes, this looks like something that needs to be factored, but from the previous lessons, do you remember that we talked about when you have something left in parentheses, it has to have a GCF of 1, meaning that nothing else can be pulled out? As I look here, they've got some stuff in common. And so from this first set of parentheses, I think we actually need to pull something out. And so when you look at 2x squared minus 8x, you could factor out a 2x. And that would leave you with x minus 4, because 2 times 1 is 2, x is x squared. 2 times negative 4 is negative 8, and then you have your x there. So this gave me 2x times x minus 4, and then I had this other case of x minus 3. And here's an example that when you factor and you have a series of products here, a series of factors, then you're actually going to have three different cases. You have a case here, a case here, and a case here. So you have three zeros. In case 1, you would say 2x is equal to 0, so you solve that, divide both sides by 2. X, of course, would be 0. In case 2, you could say x minus 4 is equal to 0. I love these. These are always easy to solve. You just move the 4 over. So x is 4. And then finally, in case 3, you could say that maybe it's the x minus 3 factor that produces the 0. And so then you move that 3 over, and x would be 3. You have three choices, so it's a finite solution. X would either equal 0, 3, or 4. And like a broken record, remember, you have to list these from least to greatest, 0, 3, 4. So we always answer, everybody has the same set of answers, and it's easy to check. All right, so now you have 7 examples on what it means to solve using factoring.